So, chapter 2.6 of Algebra 1, we're going to talk about ratios and proportions. So we probably first should start off with defining what's a ratio versus a proportion. What is a ratio? So yes, it's a comparison between two numbers with division. Okay, so it has division. So a ratio can be something like A over B, A to B. Yeah? So what's a proportion then? A proportions. What? It's just a comparison of two ratios. So it's the equaling of two ratios. Equaling of two ratios. So you might get something like A over B equals C over D. That'll work. Okay? And so if you were to ask you, like our example next, if two ratios are proportional, would have to mean that both ratios, or fractions if you want to go that way, are equivalent. So determine if they are equivalent. I'm going to have to make those larger for us to see them on the screen, but that's what we'll have to do. So made it larger, but then I cut off the final problem. That's okay. I think a couple of these would be good enough. So the question is here is determine whether these ratios are equivalent. Are the fractions the same? Yes. And to do this, all I'm going to ask you to do is simplify each fraction to its lowest, right? And then they should be the same.
Can't you just divide 24 by 3 and 16 by 2?
You cannot divide the top and bottom by different numbers. No. So essentially, you have to be able to divide the top and bottom by the same amount. So 2 divided by 3. Is that fully reduced? Yes. 2/3 is fully reduced number, so 2/3 stays 2/3. But 16 over 24, those are both divisible by what?
4.
A 4. Okay, so let's do 4. 16 divided by 4 is 4, and 24 divided by 4 is 6. Wait a minute. 4 over 6 can also be reduced, though. You can divide the top and bottom by 2 over 3. So if I divide the top by 2, the bottom by 2, I'll have 2 over 3. Are these equal? Yes. Yes. So therefore, the question asks, are they equivalent? Yes. Sorry, maybe I should go up here and show that I am dividing by 4 first. What I do to the top, the bottom. Now it wants to know, is 6/10 equivalent to 2/5? First of all, 2/5, is that already reduced? So I'm just going to keep 2/5 coming down the line here. What can I divide the top and bottom by on 6/10? By 2. Divide by 2. Divide by 2. 6 divided by 2? It's 3. 10 divided by 2. Are these equal? They're not equal. Throw a line through there, so they're not equal. So the answer is no. Not so bad, is it? If I gave you about 50 problems like that for your homework, you guys would have that done in about 5 minutes, yes?
Maybe.
So, we like those. For this one, guys, I just took a picture out of the book and said, hey, they are naming some things here. They actually have the means extremes property of proportions. And they're saying that what we can do is we can take a proportion, A over B equals C over D, that we talked about before. If I multiply both sides by B, it'll cancel the B on the left, but then a B will be up on top, right? On the right. And if I multiply by D, it'll be gone on the right side, but end up being on the left. You will get something like AD equals BC. Can you guys agree with this? And so we end up having that idea that you can, sometimes we call that cross-multiplying. But we also, up above, have the proportions set up differently. How is that set up?
1.2 by 9.
It almost seems like this is A to B equals C to D. Maybe it should be a lowercase d. Can you guys kind of see that the dots are standing for the division bar? So the same ratio of A to B should be the same as C to D. And what they're saying, guys, is that the B and the C, one's closest to each other, which is the denominator of the first fraction and the numerator of the second, they call that the means. The middle, right? The average, like the middle terms. And the A and the B, which are all the way on the outside, they call those the extremes. So part of your homework, it's going to ask you what's the means, what's the extremes. But the thing that I would take from this slide is this right here. We call that cross-multiplying. You guys remember that cross-multiplying idea? Mm-hmm. Multiplying corners. So A times D equals B times C. That's the biggest thing that I would take from here. So, can we try some examples with this?
Yeah.
Okay, cross products. Use cross products to determine whether each pair of ratios forms a proportion. Now wait a minute. To be proportional, the fractions have to be the what? Same. So when I multiply their cross products, what should be? They should be the same. So that means A times D equals B times C. Okay? So that's 0.3 over 1.5 should equal 0.5 over 2. Guys, there's a whole bunch of decimals on this thing. I don't want to mess with this. I don't like decimals inside fractions, first of all, you know, in the long run. But one easy way to take care of this is to just cross-multiply. Multiply those, and multiply those, and they should be equal. So the question is 0.3 times 2 equal to 1.5 times 0.5? What's 0.3 times 2? 0.3 times 2. Fritz? It's 0.6 equals 1.5 divided by 2, or half of 1.5. What is it? Chuck? It's 0.75. Are they the same? No. So are they proportional? No. Guys, do you see all the work that I'm putting into this? I need to see that. Everyone. Not just no. For all I know, you looked at someone's paper and saw, oh, there's a no. I'll put that too. Next problem. This one is 2 over 3.5 equals 8 over 14. Oh, sorry. Should be no equals yet, right? Okay. So what do we get? If we're going to show work, what's it going to be? At this point, we'll put an equal sign there so we can cross multiply. Yeah.
I still don't see why you can't just divide 8 and 2, and then that equals 4. So you just divide 14. Wait, you multiply 3.5 times 4.
So I want to multiply my corners. 2 times 14 equals 8 times 3.5. What's 2 times 14? 28. What's 8 times 3.5? What's 8 times 3? 24. Half of 8? And what's 24 plus 4?
28.
So, is that true? So are they proportional? Yes. (15 over 36), we'll say, does that equal 35 over 42? What is your gut feeling on this one without even having to do this? Because these are fairly large numbers. First of all, 15 divided by 36. Is that more or less than half? 15 divided by 36. It's less than half, because half of 36 is 18, right? Take a look at 35. Is 35 more or less than half of 42? It's more. So the answer to this one should be no. But we still have to write it. 15 times 42 should equal 36 times 35. What's 15 times 42? You get what? 470? 410. Equals 36 times 35. What do we get? 200? 36 times 35?
You said 15 times 42?
I don't know. I'm just taking numbers that someone actually is feeding me here. 36 times 35. 1260. Okay, so I'll go back and check to make sure that 15 times 42 is 410.
It's not.
It's not. Oh. What is it? 630. But are they the same either way?
No.
So the answer is no. Not so bad, right, Fritz? So what we're going to do here is we will be solving a proportion. So now they're saying this is proportional, and they're actually saying we don't know one of the pieces. And so now you have to solve for it. And we'll solve for this using cross multiplication. That is x over 10 equals 3/5. There's a couple different ways to handle this, but I think the easiest, most universal way would be to cross multiply. So, cross multiply, essentially multiply both sides by 10 and a 5. So you get, what's x times 5?
Something.
What's x times 5, guys?
5x.
5x equals 3 times 10. 30. To get x by itself, I'm going to do what?
Divide 30.
Divide both sides by 5. So x will equal 30 divided by 5, which is 6. You guys could check your work by plugging 6 back in for x and seeing if it works true. Check your work. Yes, the easiest way to do this, guys, is they got x divided by 10.
No.
Multiply both sides by 10. You'll be done.
Or you can divide 10 and 5, and then multiply 3 times 10 divided by
Right, you could see that go from a 5 to a 10, you would have to multiply by 2, so therefore 3 times 2 is 6. Multiple ways, but I'm going to show you a universal method that will work even when the numbers are not nice. Because it's not always going to work out to be nice. Or, like the next problem here, again, there are shortcut ways to do this, but if we keep things universal, it's always going to work. X minus 2 over 14 equals 2/7. So what I'm going to do is cross multiply. 14 times 2. It's 28, yes? Equals 7 times x minus 2. And I will write that down. Because now it becomes a multi-step problem. And you guys should be able to handle this. What if I told you from this particular setup that there's an easier way and a slower way, or a longer way? Like short way, long way. Someone give me a method to solve this. Distribute the 7. That's the long way. What's the short way then? The whole point is to get x by itself, right?
You can...
Order of operations say I should subtract 2 first and then multiply by 7.
Right.
That's the check. To solve,
So what I would do is I would divide 28 from 7, or yeah, 28 divided by 7, and that would be 4. So you know that the answer has to be 4. So just plug in 6.
okay. I'm gonna jump in here and say I'm not just gonna divide 28 by 7. I will divide both sides by 7. So yes, recognize that I want to get rid of the 7 because it's like the last thing I'll do on that side. So it's the first thing I have to do to get x by itself. Divide both sides by 7, and 28 divided by 7 is 4. And now I have x minus 2 equals 4. And so to get x by itself, I'm going to add 2. So x is equal to 6. And you can check that. What's 6 minus 2?
4.
It's 4. 4 divided by 14, is that the same as 2/7? Yes. What we have to do now is talk about rates and unit rates. Guys, a rate is the ratio of two measurements having different units of measure. Miles per hour is a rate. Cost per item is a rate. $2 per pencil, right? Or whatever it is. 25 cents a candy bar. Per candy bar, it's a rate, it's a fraction. The unit rate, guys, is a rate that tells how many of one item is being compared to one of another item. That's a little confusing. That's the way the book states it. So instead of me saying on the lines of 5 pens for $10, that's a rate. So we could write that as 5 pens, $10, right? Does everybody understand that would be a rate?
Mm-hmm.
The unit rate, guys, would be that particular fraction reduced to get 1 pen.
So you just divide.
So I can divide the top and bottom by what? Not everyone's sleeping, just a few. What's the rest of you guys going to say? What's my unit rate?
Oh, 2.
Equals 1 pen for $2. So now I can use that unit rate for next time and say, what if I wanted to buy 100 pens? How much is it going to cost me?
$50.
$200?
Oh,
One,
yeah,
one
yeah,
pen's
yeah.
two
Right.
$2. Okay? So, here we go. It's the rate of growth. In the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open in the next 3 years? So basically, I got to find a rate out of this. What's the rate? Someone other than Mike want to answer today? Okay, Parker says what? 232. What are my units on this? Because remember, rates should have units.
2 years.
2 years.
Over 232
Stores.
So just
Is that the only way that I could write that rate?
no.
Could I have also said that it was 232 stores for 2 years? That's the rate. Those are rates. Are those the unit rates as well? Can they be reduced?
Yes.
How can we reduce each one of those?
Divide it, and it's 116.
Divide both of them, top and bottoms, by 2.
2, yeah.
So if I divide 2 divided by 2, I get
And
1 year. How many stores?
116.
116 stores.
And you multiply that by 3.
Now, this one would be 116 stores for 1 year. Is everybody okay with that? Now, think of this. It says, if the rate of growth remains constant at those rates, they mean the same thing, how many stores will the retailer open in the next 3 years?
348.
So, this is where choosing your rate appropriately is very important. Because if I have the correct rate, I can multiply it by the new piece of info to figure out how much is there. If I want to multiply it by the number of years, 3 years, which one of these rates, first one or second one, will allow me to cancel out the years and just have stores? First one or second one? Remember, when you multiply with units, if there's one on top and one on bottom, the key units will cancel. So, nobody's giving me answers. So, here we go. I am going to multiply 1 year over 116 stores times 3 years. What does this equal? What is that going to equal? Parker?
348 stores.
No, it's not. It's not going to give me 348 stars.
No, you have to
What
add
does
that.
this one give me? This one will give me 3 years squared over 116 stores. Now, what the heck does that mean? Anything? I don't think it means anything useful for us. That's not the correct way to use our rate. Guys, to use our rates, we want units to cancel. So I actually want to say 116 stores per year, because when I multiply it by 3 years, the units will cancel, leaving me with an answer of 348 stores, because the units of stores do not cancel. I'm left with 116 times 3, which is 148. So, both of these are correct. That is the rate. So if I say, give me the unit rate, those are it. Those work. But to use it, I have to make sure that my units will cancel, so I'll choose the appropriate rate. Okay? So be very careful on that. And the last slide. We talked about scales, scale models, all of those things. Some of us may have put a model together. We're not making a model that was the actual size of what we're putting together. So, a scale, guys, is a ratio of the length in the drawing or model to the length of the real thing. So if a scale is 1 to 2, means that for 1 inch on your model, the real life thing is 2 inches. So 1/2 or 1 to 2 is half the size of the real thing, right? A 1/32, it's 1/32 of, so 1 inch on your model is 35 inches on the real thing. And a scale model uses that scale of something too large or small to be convenient at actual size. So if I wanted to make a drawing of an airplane on the board, it'd be really hard to draw the real thing on the board. So we might be talking about a scaled down drawing, especially if I was trying to show where is everybody going to sit when we take a trip. I'll make a scale drawing of the cabin and all the seats, and then I can assign you places on, in those seats, right? So for our example, it says on a model airplane, the scale is 5 centimeters is equal to 2 meters. If the model's wingspan is 28.5 centimeters, what is the actual wingspan? Here's the thing. We have a rate, guys. There's 2 rates here. Let me take care of this line inside here. We have 5 centimeters is to 2 meters. Yes? Or 2 meters is to 5 centimeters. You guys agree that both of those are our rates? The question is that if I start with 28.5 centimeters, which is my scaled drawing or model, what is that in real life? I mean, 28.5 centimeters, that's, not too big for a model. What's it like in real life? How can I cancel centimeters? I have to multiply it by something with centimeters on the bottom. So I need to choose this one of 2 meters over 5 centimeters. So therefore, my centimeters will cancel. I'm left in meters. What's 28.5 times 2? And then divide it by 5. 28.5. What's 28 times 2? Come on, guys. 28 plus 28. Fritz? 56. A half times 2 is 1. So that makes us 57. So we end up with 57 over 5 meters. Or if you can divide that out, you end up with 11 point what? 4? 11.4 meters. It's pretty big, right? Probably not the biggest airplane wingspan ever, but if you think about it, from one tip of the wing to the other, 11.5 meters. A meter is over 3 feet, right, by a couple inches. So it's about 10 yards. Just over 10 yards. You're probably talking about like a little Cessna, right? A little 2-seater. 2.6 homework, page 115, 9 through 32, every 3. Have a fantastic day.